I'm going to take you through a couple of problems from the Solution Stoichiometry Problems worksheet. We're going to go through about the first 2.5 and let you finish the other problems on your own, so you can see how much you've picked up. So the first step, of course, in this first problem is to come up with a balanced equation. So go ahead and do that. You can pause if you want to, and then go ahead and see if you can see what you can come up with for the balanced equation for this one. Okay, so there you go. Double replacement reaction. You do need to balance with a 2 in front of sodium chloride and a 2 in front of sodium acetate. So the question is asking how many liters of 1.88 molar sodium chloride would you need to react with 88.7 liters of 0.55 molar lead 2 acetate. So we've got 2 molarities and 1 volume. Remember that we always start with volume when we're solving a problem. So we're going to start with the 88.7 liters of lead 2 acetate. So if you look at my plan here, I'm starting with liters of lead 2 acetate, and I'm taking that all the way to what I'm being asked for, which is liters of NaCl. So that's my plan. You should be able to come up with a plan of that like that on your own, and I'm going to ask you to do that in the future problems, but for this one I just kind of, to show you what it would look like, I did that for you. Okay, so let's go ahead and get started. I'm going to set up the work starting with liters of lead 2 acetate. So we do have 88.7 liters of it. So we're just going to start with that over 1. 88.7 liters of lead 2 acetate over 1. And we're going to need lots of space for most of these problems. So I'm going to try to be compact here as much as I can. But I'm going to try to get rid of liters of lead 2 acetate. And then if you look at the plan, you should be able to tell what we're going to go to next, which is moles of lead 2 acetate. And if to fill in this relationship, I'm going to go to the molarity. So the molarity of the lead 2 acetate was given to me as 0.55 molar. Remember that molar means moles per liter. That's moles per 1 liter. So I'm going to put a 1 next to liters, and I'm going to put 0.55 next to moles. Okay, that cancels liters of lead 2 acetate. And then we're going to go to moles of NaCl. So moles on the bottom will be moles of lead 2 acetate. And on the top, we're going to have moles of NaCl. And that, of course, comes from the balanced equation, right? So 2 moles of NaCl for every 1 mole of lead 2 acetate. Okay, and then it looks like my last step is to go to liters of NaCl. So I'm going to put moles NaCl on the bottom, liters on the top. And again, where does that relationship come from? So it comes from the molarity. 1 liter is, in this case, equal to 1.88 moles of sodium chloride. All right, so if I do the math, multiply across the top, multiply across the bottom, and then divide, we should get 51.9, or with 2 sig figs, 52 liters of NaCl. And there we go. All right, and that answer is kind of in line with my starting number. It's a big volume, but so is my starting number, which was 88.7 liters. Okay. So for the next one, let's come up with a balanced equation. Okay, and there you have it. There's our balanced equation, just a single replacement reaction. So the next step, of course, is to come up with the plan. So what are we starting with? What are we ending with? See if you can come up with that on your own. Okay, hopefully you came up with a plan something like this. You're being asked for milliliters of iron 3 chloride, so that's where I'm ending, milliliters of FeCl3. And you're being given 1.55 moles of magnesium, so that's where we start. We're also given the molarity of the iron 3 chloride, but we never start with molarity. That's just going to be a tool that allows us to go from moles to liters of the iron 3 chloride. Okay, so let's go ahead and set up our work here. 1.55 moles of magnesium is my starting point, so that's going to go over 1. And then, so what am I trying to cancel? Should be moles of magnesium, right? And then from moles of magnesium, my plan tells me I'm going to go to moles of FeCl3. And of course that comes from the balanced equation. I'm going to do something a little different this time. I'm going to go ahead and set up all the units, and then I'm going to worry about the numbers. So right now, I'm going to be canceling moles of Mg. So the next step is to cancel moles of FeCl3. And if I look at my plan, from moles of FeCl3, the next step is liters. So liters is going to go on top. Again, I'll worry about numbers a little bit later. And then from liters, I'm going to go to milliliters. And that should give me my answer, because milliliters of FeCl3 is what the problem is asking me for. So let's go ahead and talk about numbers here. What number should go next to moles of FeCl3? Okay, so it should be a 2. That comes from the balanced equation. And then a 3 in front of magnesium, right? Okay, how about this ratio here? What number goes next to moles of FeCl3 if I have liters on top? Okay, so this is where the molarity goes. So in this case, it's going to be 0.720 moles because of that, and that's per 1 liter. Okay, so that allows me to cancel moles of FeCl3. And then what number goes next to milliliters? Good, should be 1,000 per 1 liter. And so if I do my math here, I should come out with a pretty big number, 1,435 milliliters. I'm going to go ahead and round that to, looks like 3 sig figs, because both numbers in the problem had 3 sig figs. So I'm going to make that 1,440 milliliters of FeCl3. And there we go. Okay, this last one I'm going to let you finish, but let's at least get it started here. Hydrogen chloride reacting with aluminum. That's a single replacement reaction. So aluminum is going to replace hydrogen. And it's going to give you AlCl3 plus H2. And then to balance this one's a little bit tricky. We end up with having, because we have a 3 in front of chlorine, or behind chlorine, and a 2 behind hydrogen, HCl over here is going to have to go to 6. And that means I'm going to have 3 hydrogens, 2 aluminum chlorides, and then that means I have 2 aluminums here. So I have to have a 2 in front of Al there. That one's a little bit tricky in terms of balancing, but there it is. Okay, so see if you can go ahead and come up with, well, let's see if you can go ahead and come up with a plan yourself here. Okay, you should have a plan that looks something like this. And then go ahead and do the work to get your answer. I'm going to go ahead and end the video here, and I'd like you to go ahead and finish this one out and also do 4 and 5. Just remember that you can always use the previous ones as examples, and if you want to hear me talk about it as well, you can always rewind and rewatch those portions of the video. But like, for example, number 2 was very similar to number 3. The only difference is on number 2 we started with moles of the first substance. Here we're starting with grams, so we just have to do a gram to mole conversion, and then the rest of the problem becomes just like number 2. Which all of you should be able to do a gram to mole conversion using the periodic table, so it shouldn't be too much of a problem. So give the rest of 3 and 4 and 5 a shot, and we'll talk about them in class next time.